Okay, now we're going to focus on quadratic transformations. This is the formula we've used all year long, even with linear equations. We've got an A, a C, and a D. We don't care about the B because A and B work together. But ultimately, we need to be able to identify our simple parent function, which is our quadratic parent function. It's the littlest quadratic function we have possible. So it's going to be y equals x squared. The reason it's a quadratic is because of that square. Okay? Now, this asks us to draw the graph of the quadratic parent function, meaning y equals x squared. All I'm going to do is I'm going to go to my calculator in my y equals screen. I'm going to clear out what I have in there. I'm going to type in x squared. I'm giving you a chance to do that, so make sure you're practicing this, you understand what I'm doing. I'm going to go to the graph. It is an easy graph, but the problem is I don't know exactly where to put my points. So I'm going to go to the table and try to find where my vertex is. My vertex is the turning point of my graph. So it's where my graph is kind of mirrored. Whatever happens on one side is going to happen to the other side. Okay? And so I'm always going to put that vertex in the middle of my table. Once I've done that, I can create the table I need. So going back to your notes, your table, I want at least 7 points on there. And that means 3 above the vertex and 3 below the vertex. And that includes, my pen's not working again, of course. There we go. So my first x is going to be -3. Oh my goodness. Okay, so it's -3, -2, -1, 0, 1, 2, and 3. Notice even though they're negatives, it's kind of the same thing happening on both sides of the 0. It's not always going to be 0, 0 as your vertex, but this happens to be your parent function, so it will be. On -3, we've got 9. On -2, we have 4. On -1, we have 1. Then we've got 0, 0. Then a 1, a 4, and a 9 again. So when we go to graph it, we're going to start at the vertex, that 0, 0 point. And whatever happens on one side of the vertex is going to happen on the other. So I'm going to plot 1, 1, and then go to -1, 1. I'm going to plot 2, 4, and then I'm going to go to -2, 4. And then I'm going to plot 3, 9, and -3, 9. And I'm going to connect the dots. Ultimately, everything, oh wow, that's a really ugly dot. Ultimately, everything on your STAR test is going to usually be compared to your parent function. So as long as you remember your quadratic parent function is y equals x squared, you can always type that into your y equals screen, look at the graph, and then compare to what happens. So, talking about our vocabulary dominoes, or our quadratic dominoes, we talked about shifts, up, down, left, right, over the x-axis, narrower or wider. The thing we've never talked about is how you flip it over the y-axis. So I would like y'all to cross that out, because that's the letter we never focused on, and we don't need to focus on it. That would be letter B in our parentheses. We don't care about B. Okay, so how do you make the graph shift up or down? That means, how do I make this vertex go up or down? Well, up or down is talking about the y-axis. And if you go look at your transformation, the thing that's going to focus on the y-axis, just like our y-intercept, is outside of everything at the very end. This tells us it's going to move up or down. So, how do you make the graph shift up or down? You change D. If it's positive, you go up. If it's negative, you go down. Now, moving left or right, if we go back to this equation, left or right happens whenever we're not expecting it to happen. So it happens inside the parentheses. Remember, if something's in the parentheses, it's like when you grab your head. So you take your hands and you're like, oh my gosh, it's inside the parentheses. So you're going like this. And the reason you're doing this is because it's trying to confuse you. The C tries to confuse you. Because when it's being added, it's actually going to move left. And if it's being subtracted inside the parentheses, it's going to move right. So inside the parentheses, put your hands on your head. It confuses you a little bit because it does the opposite of what you think it should do. So in order to make something move left or right, we're going to change C. If we add, it's going to go left. If we subtract, it's going to go right. And here's your key word for the next one, flip. This comes from your quadratic dominoes yet again. Flip is another way to say the word reflection. And it's just like on a linear equation, the way we make something become a positive slope or negative slope is by looking at that number in front of our x. The only thing that's in front of our x is an a. So we're going to change A, but flipping means it's either going to go up or down. So if it goes up, it's got to be a positive A. If it's a negative parabola, it's going to go down. So the only thing that flips is the sign of A. And the last thing we're going to talk about is making something narrower or wider, which technically means stretch or compress. The only way we can do that is by changing that number in front of our x. The only number in front of our x would be letter A. Let me go ahead and highlight that. So A changes if it's going to be narrow or wide. So we've got to think about if A is a fraction, it compresses. Or fat. Or flatter, fatter, same thing. Okay, your quadratic will compress down. It's like you're pressing it down, stretching it out. Okay, making it wide. So if your A is a fraction, it gets flatter. If your A is greater than 1, you're going to stretch to the big numbers. Stretch, 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 stretch. So your graph is going to get really skinny and stretch up to the big numbers. Good job.